we can start talking a little bit. What really got you hooked in to these software engineering practices, and what do you see in it? To what is the value on it, so that we can really improve our ML projects?
I think probably Laszlo should start off. I think he has quite a bit more
Yeah.
experience in this realm. I can then maybe add some sort of my experience in this.
Yeah. So I spent 4 years at this startup, and the beginning was pretty much software engineering. So I learned how to do test-driven development and all of these parts. And then when we moved into like heavy machine learning parts, then I was starting to question of why this is much harder than writing code. And then what works there, and what should be improved, what can we take it over. And then it turns out to be very, very beneficial. We trained the team as well. So my team, we're about 5 people, and we became much more productive. And we broke it down to like first principles, and then use that principles of why they apply to machine learning. And this led to a more efficient and more motivated like code writing procedure. And we were able to move much faster than as a team of our size was supposed to.
Yeah, from my background, I'm a self-taught programmer. So the first sort of job as a startup as a data scientist was sort of being thrown into the water. And there was a small team. We fortunately had like a pretty good culture. There were some people with a bit more experience, more in traditional software engineering. So I got exposed to a lot of the sort of, I don't know, really general best practices with software engineering with that job, and pretty quickly realized I don't know, just the benefits of using the experience of software engineering has learned over the last 20 years with testing and these sort of things. And there's so many instances where having tests just saved our butts and helped us fix things faster and move and be more productive, similar to what Laszlo says. And then I think since that role, I've been largely in larger companies with larger teams of data scientists, and what I see often is a lack of sort of using best practices, and it leads to sort of maybe this feeling of being productive in the beginning when you're and I'm coming from the perspective of a data scientist, but maybe the feeling in the beginning that you're really being productive and experimenting with things, but then quickly, once you have something that's needs to be put into production, I think everyone can relate to this. You just quickly realize what kind of mess you've gotten yourself into. So my interest in this is coming from trying to just improve and get myself in a position where when I'm in a team, that the things that we're producing are a bit more easy to maintain and just a better quality. So that's where I'm coming from.
Very nice, very nice. So, Tim, can you share with us a concrete experience where you didn't use, like, were not using the best practice in the beginning, and then it might have bitten you later down the road, and what you learned from it, and what are you now doing to not do it again?
I can unfortunately give you many examples of this. Sometimes it's in my current position, there's been several instances where I've sort of come into a project what's already in sort of in the middle of the project, and sort of seeing, okay, the code base is not in a great position, and then just having to sort of work with other people to improve the quality over time, because maybe something's already in production and it's just biting you in the butt all the time with whatever things not breaking and there not being enough tests and those sort of things. So and I think we'll maybe get into this later with this idea of like strategic versus tactical software development. I actually never heard this term before today when you sent me these notes, but it's a nice way to think about it, because it feels like a lot of the projects that I've worked on have really just approached it from a tactical way of getting things out really quickly and not sort of thinking about the design. And what I find is really interesting, hopefully that we could discuss, is this sort of when to use the different approaches, because I think there's an argument to be made that sometimes it's good to be able to move fast and prototype and things in machine learning and data science. I have a lot of examples. I don't know. I think that's
okay.
Maybe one for now. Yeah. So.
Maybe a good topic that we can discuss further as well is the testing one. Maybe if Laszlo has some experience on it, because even me or even the audience, yeah, everyone, feel free to interrupt us, ask questions as well to the Laszlo, to Tim. Feel free. I'll maybe do this one, and maybe if Laszlo has some experience, and even you, Tim, of course, regarding testing, like a common question that I still have and a lot of doubts on it is really how should one test, like for example, features and pre-processing data. Great Expectations can be a great tool for that. But what about modeling? How can you really test your implementations regarding your modeling?
Yeah, I mean, it's a great question. Like, but you can also ask of why do you actually need tests, or what is testing? Because one classic example, and what Tim was talking about, how can you get yourself into this mess? It's like that's a sign of a broken process, that you are somehow afraid of your work, and that's not a great place to be, because as an effective technologist, you want to be in control of your own work. It does what you want. It's like you are in power. And this is what you are losing if you are not testing, and if you are creating this kind of messy solutions, because it's like you start worrying about, it's like, what happens if I reset my notebook? It's like, I lose my progress. It's like I can't get back to where I was easily because I forget how to do it. And these are practices which are like dangerous. It doesn't mean that you always need to practice this, but usually you're probably better off. And there are other like principles what you, as a professional whose job is to create productionized solutions, or really need to adhere to. For example, you owe this to the company to create solutions that are well maintained. You're not working for yourself. You're not creating like value for yourself, but for the company. It's like you need to prove that you have worked, and then you created some kind of value. And this is why, for example, you use most of the time version control, because until something is not version control, that doesn't really exist for the company. You haven't really created anything. This is not data analysis where you do the analysis and then report the numbers, and then you can forget the entire solution. And I think this is one of the, this kind of bad habits that's coming from analysis, that you don't take care of your own code. And so that's one thing. The second, the code base is not yours. This is why you do code reviews. You need to conduct in a way that we are creating together some kind of solutions, and then creating it in a code base that is essentially owned by the company. So it's not like when someone criticizes my code, it's like I don't take it personally, because it's we are doing it together. So it means that you need to you have all the rights to criticize my work. And actually in our previous company, when you do a code review, and the reviewer can only merge your solutions, and the reviewer is responsible for the code, not the person who wrote it, because now you are in charge. Now reviewing is actually an important work, because that from now on you are in charge of that solution. Yeah, so this kind of principle is what's very important to know. And what I personally think, Jeff Bezos have this concept of type 1 and type 2 decisions. So it means that type 1 decision is that you can't come back from. It's like if you make it, then there is no way to undo it. And type 2 decisions is like, it's like, let's do it, and then we can move, like we can undo it easily. And I think this is why you need to have like a very structured solution, version controlled and tested, because that's what you gain. You turn your type 1 decisions into type 2 decisions, and then instead of worrying that your notebook goes down, or how did I do this processing step, like a month ago when it was wrote, you can undo this, and you can think about your solutions as a well-structured, solution, like real solution, and operate on it in a professional. Does it make sense?
Yeah, I think a lot of some ideas that even reproducibility, I think you brought up to the table as well. It's really important to be able to come back and see and reproduce it again. Okay. Tim, do you want to add something on top?
Yeah, I think Laszlo just started by saying like how do we get into these messes? And I think coming from a sort of person not from a really heavy software engineering background who's interested in it, but coming more from a data science thing, is what I hear from my colleagues often is that they're just experimenting and trying things out, and they don't think of themselves as writing software. And I try to argue with them that, okay, the second you start writing code and using version control and committing it, you're writing software there, whether you want to believe that or not. So like trying to get these sort of best practices built into the culture, I think is the big hurdle, coming from again, from a data science perspective, sort of convincing people that it's worth their time and showing them, okay, it may be a bit slower in the beginning when you're learning these things to get some solution out or get a prototype out, but in the long run, you just save yourself so much time when you do things a bit more strategically and thinking in like a bigger picture about how things work.
Yeah, it's good that you mentioned experimenting, because it's, what do you mean by when you are experimenting? Like what's the output of this experiment? You know, how do you record your failed experiments, and how do you record, you know, how do you know which part of your experiments are relevant and that will gonna go into production? And I think this is why you need to have from early on a relatively strict version control, because you don't want to, you know, recover this chain of evidence back to when you started the project in EDA, that okay, this kind of processing step is relevant, but this one is not, you know, but I don't remember which one. And, you know, in a month you can have a lot. And I think this is important. You are working for the company, you know, all of these experiments are relevant information because you are stopping from someone else redoing them in the near future. If you are working on the same domain, you know, it's quite possible that the same person, another person in your team, will going to have the same idea and we're going to try the same thing and we're going to fail the same way as you failed. So you are paying forward negative experiments as well.
So,
I think,
go ahead.
Oh, sorry, one last thing. I think it was from Joel Gruth said something about how he finds it a bit funny that people talk about, oh, I'm just experimenting and then producing really maybe poorly written code, as if that's some excuse that you're experimenting. But if you're thinking about doing like science, hard sort of science, and you're doing experimentation, of course you would like document everything and try to be really robust about it. So it seems kind of contradictory in the realm of data science to use as an excuse to be sloppy. So I found that a good way of thinking about it.
So on the ML projects that you work, from the get-go, you start, for example, doing experiment tracking either with DBC or MLflow from the start?
Yeah, sorry. Go ahead, Laszlo.
Yeah, go ahead. you, because I'm going to be embarrassing, but.
Oh, no, it's okay. Go ahead.
Yeah, I'm not sure whether you are producing experiments that are worth tracking at that level at early on. You are more tracking the steps you are doing and the way you are thinking about this problem. Because at that point, probably the results are not, you know, worth keeping, you know. So actually version control data is only at a very late stage, only when like there is a flow, and probably we can talk about it later of how do we approach a problem, and then how do we start iterating early on, and what does it mean to have a refactoring facility very early on, even when at the POC level, because you need to maintain code quality. Code quality maintaining requires refactoring. Refactoring requires testing. But what do you test on if you are just started your project? You know, mm-hmm. And usually what you do is like you have like a small set of data, like which is statistically not relevant, but it is testing the correctness of the code base. You know, you're not going to get good models if you train something on, you know, 0.1% of the data, but you still have the entire pipeline. You can run it in 1 minute. You know, you can do a refactoring step and then do the entire thing. So that's an infrastructure what we are doing early on. And then obviously, as we are progressing with the ideas, you start adding more and more data until you reach a state when you can run the entire pipeline, and then you record the data, and that is an experiment. When you have a statistically relevant, solution with the entire code base, and then you can do like in notebooks, you can do like further EDA, because essentially you have a solution. You still need to validate the results on that, right?
Yep.
Yeah, maybe an example of something I was working on recently, and like yeah, I don't know if this touches on what we're talking about, but this thing just came to mind is that I'm working in a team of like 5 data scientists, 3 data scientists and 2 data engineers. We're doing some forecasting on sales with promotions. And we're doing like a proof of concept thing for using like a machine learning based approach to it, because till now it's been pretty heuristic based and not very, very complex. And the tendency with my team was basically like, we had some BigQuery data set, was basically, we have a short amount of time to work on a POC, and they're like, everyone was just like writing ad hoc SQL queries on BigQuery, and then maybe building up some pipeline. Maybe it's in notebooks or in scripts, in Python scripts or whatever. And this is like back to your original question, Andre, about like how you build in these practices. Was like what I tried to do is step in and say, okay, how can we like write this in a bit of a modular way where we can introduce tests about like we're very sure that we're pulling the exact same data. And then another thing that came up recently, and I think I asked this in one of the chats in the community, was about using a feature store, because something I've noticed is that people maybe pull data and then start doing feature engineering and come up with really crazy features, but then there's like the sharing between things is really hard. And so I was looking into this idea of using a feature store of like, okay, how do we create features on our own, so try to like not block people in doing experimentation with features, but then once we realize that, okay, this is a useful feature, how do we share this? And these are sort of the things that we're trying to build in. So
that's I think that I'm also feeling the same way in the company that I'm working with. I'm currently doing consultancy for a third-party company, and our goal in that company is exactly the same. There are a lot of different data scientists working on parallel projects, and they sometimes use the same features, and there should be some sort of features store concept where you avoid all of that double work that you just mentioned. I think that's really, really important and very useful as well.
Okay, sorry for interjecting into, because both of you mentioned like low-level infrastructure parts like BigQuery and feature stores. And from a solution point of view, these are implementation details. So it's very important to maintain, and I think Oosterhout talks about that, but Knut talks about that, and everyone else talks about that, what's called layers of abstraction. And a feature store is not really, that's the lowest level, at an infrastructure level solution. At your POC level, you are worried about the actual algorithm that is going to generate this feature store. And to be effective, you need to be able to run this code on, a CSV or a Pandas or BigQuery, and eventually this is what you are going to ship, and MLOps team will going to deal with the feature store, and you are just going to ship the actual features, the calculation of these features. And this is exactly what good design is I can test this piece of code that generates the feature on my own, and everyone else who are working parallel projects, and we have our own CSVs, and then run tests in one second or 1 minute, but then we can publish them into a common place where the MLOps team can figure out how to run it on an entire database. And I think this is like the testability part of good code quality, that I can iterate on it fast, and then I know that the same code was shipped, that I know that it's going correctly in my environment.
Good. Okay, I have a follow-up question for both of you guys regarding these feature engineering processes and testing it. When do you start? For example, imagine that you are iterating on a model, right? You are like, and you keep the algorithm constant, and you are more working on sort of data-driven approach where you start with more and more features, you keep adding features. So for each feature added, you instantly create tests for it regarding the pre-processing of it, or you only write tests once you see that feature being promising?
Maybe you can go first, Les. My daughter's crying really loudly, so
good excuse. No worries. Yeah. So usually what we do is like this kind of functional or regression test where we record what the output's supposed to be and then compare our code to this estimated output, and then monitor of what's the difference between them. So it means that if you make a breaking change or you make a change, then you're supposed to see a difference, and then if you see this difference, then you can evaluate whether what you did is correct or not. And then you swap the reference values to the new values, because clearly when you are dealing with like feature engineering, you are changing the output of the model or your input of the model, like a measurement point in the testing pipeline, you're changing. So it means that and the values are not unit testable. It's not something like like I would like this 20-day moving average to be my feature. It's like the only way to unit test this is to actually explicitly re-implement the code and put it into the test, but that's not very effective way to solve this problem. This is why we recommend like functional testing anytime when you are in doubt, and then just maintain whether you move forward, and that helps.
I don't have much to add to that. I think the approach that Leslie talks about is probably better than the way, because the way, and this is I think coming back to the thing we just talked about before the meeting, Andre, is sort of like seeing, I think a lot of people, and myself included, are sort of familiar with what a unit test is or an integration test or whatever, but actually knowing when to deploy it and when it's just kind of, you're just adding work for yourself, it's actually not increasing the robustness of the system or giving you more trust in it. I think specifically in the data science and ML space, I think there's a lot of lacking examples of that. So I think, I don't know, because my approach, and probably Les, I think this, I'd like to hear your feedback on this, but like if I was writing some sort of function that was doing some sort of feature engineering thing, if there's any logic within that function, I would try to like write some sort of unit test for it and maybe mock data that I would plug into the function and then expect, and then see if the output is doing exactly what I expect it to do, and if all the like edge cases about how it could go wrong are being handled correctly. But maybe that's not the right way of doing it. I don't know.
Yeah, that is a classic unit testing case. If probably edge cases are relevant to test, like when do you throw an error, how do you handle zeros, negative numbers or anything like that, partly because they can cause in a production pipeline like permanent errors. If it takes down the pipeline, you're going to have problems. So probably these are issues what you would like to handle. But the problem is that most of the time you are facing in specifications in machine learning that are numerical. I would like this number to be calculated, and there is no trivial way to solve this for the majority of cases. So what's the point of talking about it as a universal tool for testing, while in a software engineering context, unit testing is pretty much a universal concept. So it means that a majority of specifications can be tested with given when then style tests. I don't think that applies to machine learning, and this is why we are not really enforcing, because the result is going to be that the machine learning engine is not going to do it. So what's the point on trying to force something that is inconvenient for most of the people, that to the point that they just defy your instructions?
Yeah, but I think that's an interesting point, because I think that's sort of the pushback I get internally from data scientists, even sometimes data engineers, is like I don't know, sometimes it seems like I'm trying to sell them on testing because they just feel like it's some extra work that we're asking them to do, and they're not actually seeing the benefit of why would I spend an extra 2 hours writing tests for all this code that I just wrote. And I think it's That's a good point.
Yeah, but I was wondering of why, if machine learning doesn't apply to, adhere to unit testing, then what else there is. And I find Kent Beck's experience from Facebook is essentially the goal of the testing is you change your code and you know how you changed it. And you can quickly validate that your entire code base is still consistent. And if you have an alternative way to do this, then you're okay. And Facebook has the alternative way was to just push it into production and catch the error as fast as they possible. But here, and this is why we do functional testing, is like, okay, you change something in your code, you run it again, and you will going to know that on the test data, it will gonna pass. On the larger test data, it will gonna pass. And then on the production data test, it's going to pass, And then you have this kind of cascading, sets of validating whether you are still consistent with what you have in your head. And that's,
I think really a good point on that might be the confidence that you have on your code working. For example, now I onboarded on a project where the guy that was there didn't build a lot of tests because the stakeholders just were requiring a lot of value being added ASAP. So he kind of needed to follow a technical approach to tackle the entire problem. And now, as I onboarded on the project, I don't have much confidence to change his code base because if I put a bug there, I won't be able to know if it's still working or not. I think that's really bring a lot of value for upcoming developers. Developers in the future are able to change the previous code base while still having a lot of confidence that they didn't break the code at all.
Yeah,
and you being one of those developers, you're not shooting yourself in the foot in the future.
Yeah.
Which I think people forget. It's not just someone abstract person in the future. It's also yourself. So
Exactly.
I think you touched on a very good point with onboarding, because one of the reasons why onboarding is difficult into legacy code bases is because it's not refactored to readable state. So readable and changeable, these are both like tech debt removal issues, and it's not refactored because it's hard to refactor. And this is why you need the testing facility, is because you continuously need to iterate on your code. This needs to be a routine that you change your code to make it nicer, easier readable. And it should be easy enough that you don't feel this is a burden, as Tim said about writing tests. It should be completely trivial to move the code around without changing functionality and still being sure that it was the right thing. It's still in a consistent state, and this is what refactoring is, to increase readability and to help someone to get on board.
In terms of percentages of your time, how much, for example, how much time do you usually spend per week regarding these best practices? Is it 10%, 20% of your work? If you could define it in terms of numbers.
Yeah, I think this is an interesting question, because, and this maybe gets to later if we discuss this book, this object design style guide, is, I think probably Laszlo spends less of his time thinking about sort of these best practices things because they're just built into his way of working, and it just comes from experience. And I think for me, after trying to read more about these things, I want to try to incorporate these things into the work that I'm doing, and trying to use whatever the things that I'm learning. But at this same time, it's also, without the experience, it's just so hard sometimes to know exactly, okay, when to use things, or am I just using something because I read it and it was told that it's sort of a best practice to use, and actually internalizing these things and knowing, okay, you use dependency injection here because it's just the most robust way of doing it, and eventually you probably stop even thinking about that. You just do it automatically. And I think someone that's sort of starting to try to learn a bit more about these things, I probably spend a bit more time really thinking about how to implement things, probably compared to someone who's a bit more experienced software engineer. So
yeah, from our perspective, this is not we don't express it in percentages, because you are just doing it. You know, that's your job.
Yeah.
If you get a task, you know, it part of the task is, you know, campsite rule, which is it means that you need to change some part of the code base, and part of the task is to clean that code base up to, if you think it's not readable, not clear for you. And you know, you can come back and say, you know, it turns out that it is much harder. Then okay, then we can reevaluate of how much energy you need to spend on this project. But it's still, you know, you need to bring that, like, now that's an identified problem, and now you need to address that problem. You can't just leave these things, because that is tech debt. That's literally tech debt of
Yeah.
if you don't maintain your code base.
Mhm.
And yeah, go ahead.
So quick question, because all this conversation is about code. How about data? What if there's a change in data, and then your test case doesn't fail to run, right? Because machine learning is not about code; it's code and data together. So how do you suggest and manage data as well as and code at the same time? Let's say, for example, you have a suite of tests that unit tests or test statistically a model's behavior, and you updated test data, and your model testing no longer works, or your training pipeline no longer works, or you know, something changes in the data and your code completely breaks. It's not the code's fault, and it's not the data's fault, but how do you manage the interactions between the two? Because managing code is easy. There's tons of literature about how to manage software engineering code bases, but machine learning is not software engineering, because we manage the data as well at the same time. So how do we bridge the gap between the two?
Tim?
Like, yeah, it's really simple to look at software engineering perspective, because it's code. But in our job, we also talk about data, right? DVC is not going to cut it. I mean, DVC is just not going to work, right? There's a lot more data than expected. Sometimes some geniuses will change some data schema upstream, and everything breaks.
Yeah. So, sorry, it's a good point. Tim, go ahead, and I'm just gonna.
Yeah, I mean, I can just specifically talk about. It's more, it goes in the area of like tooling and what we're using and why, and what I found effective. I don't know, like for example, again, this gets into like sort of abstractions, as I was talking before, but like we work on BigQuery, and we ingest data into it, and then we do tons of transformations, and we found that the DBT, its data build tool, is like invaluable for us for testing exactly these sort of things, that like whatever the data is not changing, and there's lots of other tools. I think Andrea mentioned Great Expectations, and I don't know, there's all sorts of ways you can test these things. But then like once the data starts getting consumed into a pipeline for machine learning, I don't really have a really good answer about how you test all of these things and that it's doing exactly like as you expect along the way. Because I think you suggested that like your pipeline would break or something if the data changes, but oftentimes it's even like trickier than that, because it doesn't break. You still get some results, but the results start looking really weird, and then you have to like somehow figure out, okay, where is this going wrong? And it's a very good question. I don't have an answer for that.
Yeah. It's thanks for bringing this up, because the one place where we explicitly have unit tests is schema definitions. So it means that before the pipeline starts, you know, there is a test on schema, and then it stops the pipeline if something changed, because it means that even if it's not affecting your pipeline, it is an unknown situation that you need to deal with. You know, someone added a column, removed a column. You know, it's like you want to be notified immediately. And our mental model was that all of these should be codified in the code. It means that, you know, the way I know what's in the database, what kind of columns there is a test, and I read the test, and if there is a new column name, that needs to be there, because that's so important from the point of view of going deeper into this one. It's very hard, because there is very little you can do without actually running the entire pipeline on the entire data, and this is how you usually. You know, you have this kind of sanity checks, and our workflow was that you need to run these semi-regularly and then do a full suite of analysis on that in notebooks, like almost like exploratory data analysis of, are we sure we are still we understand what's going on in the database, and check, for example, there are certain things like null values or empty values which are happening. You can't do anything about that, but you don't want 99% of one column to be nulls if there's supposed to be some values there. This kind of analyzes what's important, but there is no really real way to do that without actually running the full pipeline. The only thing what you would like to do is that when you start the pipeline, it is going to run, because you can say, okay, this pipeline takes 8 hours to run. It means that you start running it, and then you check the results at the end of the day. You don't want it to realize that it failed. So we need to keep the model in a state, or the code base in a state that know that when you start a pipeline, it will gonna finish, and then next day you can analyze the results. Does it make sense, Han?
Yeah, it kind of makes sense, but that's more on the data processing side, right? Let's say if you are trying to unit test a model, or you're trying to test a model, integration, whatever test, or acceptance test. That's called an acceptance test model. Let's say your existing model definition is you want the model to have just arbitrarily 99% accuracy. And sometimes next month, when you get the new batch of data coming in as your test data, and the model accuracy drops. So then the test will flag, your daily runner will, flag that error, and you will have to go back and fix your code or something similar to that, right? Because there's interactions, right? Because we're not talking about versioning code only, we're also talking about versioning the data part, and how do you manage the interaction between the two. I mean, using DVC sounds fine, but it gets really, really messy. It gets really, really extremely messy. So it's better for me, it's better to decouple the two. But then it's still difficult. It's not just like model schema changes, right? There's data schema changes. There's also data distribution changes, right? Let's say, for example, your population shifted.
I think maybe you're touching really on monitoring. For example, you could monitor your feature distribution, all of that, missing values. You can maybe monitoring, I think might be a good solution for that. For example, like Laszlo was saying, some features can be like all of them null. Maybe if you have monitoring in place beforehand, you would instantly detect that, and maybe even create an alert and alert all your data science team that your feature vector is becoming really affected by your data quality upstream.
And I think it's completely domain specific too. Like sometimes like you have to have experience to know, okay, where can this go wrong, and like what does a weird value look like for a feature or a result or all these things. And then the question is, as you say, it's just like how do you keep track of that in an effective way, and so you can build a better and more robust system.
Right, but the problem with monitoring is it's catching things in production, which is not actually a problem, but then you have to backfill that to your workflow process. So you go from monitoring and go back directly into like your dev environment, right? Because usually you want to keep things in traditional software, you keep things in one single direction from dev to staging to prod, and you don't rarely go back. There's rarely a feedback loop. But for data, if you monitor that way, that's a big feedback loop, and then it makes the whole process pretty messy, right? And then you have to convince people like how do you convince people on how to best, let's say, set up a data store that tracks different versions of your reference test data, and how do you determine what to include in your reference test data for every single version? Like how do you like make the decision for those.
Yeah.
I'm just curious on different people's workflow.
Yeah, to be honest, I think that kind of the example you gave is that the model performance drops because of a new batch of data. I think that's where traditional software engineering testing ends. You know, it's like that's not a traditional software engineering problem. That's essentially a data analysis problem. And I think we shouldn't automate or try to like shoehorn some software engineering solution for that. It's like the fact that a model performance dropped is a data scientist's job to monitor and find out. You know, it's like, why did this happen? Because there's so many issues can happen. Is that I don't think that you can just, you know, you can put anomaly detection on it or some other automated feature, but it's almost certainly requires your attention to deal with this, and it's not very codifiable in software. So I like this is one of the places where I say it's like, you know, it's like you stop worrying about software engineering. You know, it's like you are an analyst now, do analysis and find out what's wrong.
Well, I think just from my perspective, engineering is engineering. It doesn't matter if it's software or hardware or machine learning. We all have different tests at different places. So the idea is not to separate out model versus code or versus data. The idea is how to, like for me, it's like I would just want to learn how you integrate all the testings together, right? So like on the software side, you will have your unit test, integration test, acceptance test, end-to-end, whatever, right? And on your modeling side, you will also have your statistical test, you have your behavioral test, you'll also have your acceptance test where the whole system is tied in together. And the workflow should be similar, should not be orthogonal to each other. So like, how do you manage this type of, I guess, a 3D system, right?
Yeah.
Or a 2D system versus just a linear like code, changing code. Just that's what I'm curious about.
It's a great question.
I think regarding the model aspect, and I think Laszlo spoke a lot 2 weeks ago about it, a major difference regarding the modeling is really you should worry about A/B testing for changes you do on your model side. If you update your algorithm, if you retrain your model, maybe deploying some canary deployment might be useful for you to detect whether or not those changes can remain in production, unlike software engineering, where just an assertion is just all you need.
Yeah, maybe I can add something else as well, because you mentioned data versioning, like test data versioning as well, and what we found is so the big difference between machine learning and traditional software engineering is traditional software engineering is instantaneous. So it means that if you make a mistake, it will going to immediately move KPIs, you know, like payment stop or the app stop or something like that. And I think that creates a different mindset. And this is why you can have unit tests and integration tests, because you immediately know that something is wrong if a test fails. But in machine learning, that's not, sometimes you are only statistically wrong. It means that it takes a long time. And here is, you mentioned that everything goes in one direction in software engineering. You know, that's not true in machine learning, because you might need to maintain multiple versions of the same thing on a very long period of time. And then, you know, roll back between them based on experience. And I think this is why that statistical part is analysis. Like I don't try to, turn it into like software engineering. I don't think that's very automatable, because there's just too many moving variables. What we found is sometimes, and I see it in other teams as well, which we consult, is the company thinks that the team can maintain an infinite number of models in production. So when they are creating a new model, there is no budget for it to maintain it or monitor it. Then what you think is that you are going to be able to put hundreds of models in production with a 5-man team. That's not true. And And what we did is that anytime you create a new model, you need to budget a really large amount of time over several months in through their life cycle, when this person will going to come back every week, every 2 weeks, every month, and then we're going to run these drift tests that we're going to look at, are we still knowing what's going on? And I think this is the analysis mentality. If a schema changes, we have a unit test on it. It will going to break the pipeline, and we are going to fix it, and then we know that we are back in track. But distribution, the mean changes a bit, or you start to have like extreme values or a fat tail or something like that. No one will going to figure this out, because you only see the KPI, the top level KPIs, which are not sensitive to this. So yeah, that's our view on this. Models are more expensive than just code.
I think you brought out a very good point, that some of these pipelines have to be run on a regular basis just to make sure nothing breaks. Like all this is, at least from my experience, it's so fragile. It's like all these pipelines will rot or break if you don't run it regularly to make sure that they still run. So like if you update one, if you create a model today and 6 months from now, and you don't run anything between now and 6 months from now, you will not be able to, you'll be in a big surprise when you try to retrain or update the model like 6 months from now, because you didn't run it on a regular basis just to make sure that everything works still.
How dangerous do you guys think it is to have like in production models? Like, for example, Tim a couple of minutes ago said that some models are kind of robust to, for example, missing values, and they are really robust for even those kind of changes. Like, for example, XGBoost and LightGBM are examples of that, where they even accept null values during training. What sort of issues do you think that might come up if you put one of those models in production and you are not really monitoring your features? Do you have some experience with this? Because like now,
just to be clear, you are not putting a single model in production. You're putting a pre-processing, a modeling, and a post-processing pipeline in one go. And the pre-processing is supposed to at least warn you that you are creating nulls or empty values or whatever. Yeah. Log you, Slack you, any kind of email you, anything. And if that happens frequently, you need to be on board, because that is something which is a software engineering problem. You can figure out that something is null. If something, the mean changes a random variable, you're not going to figure that out. But that's an issue. And I think it's important to think about this, that the pre-processing part is part of the model.
Okay.
Tim? Sorry.
I have nothing really to add to that.
Yeah,
I can just sort of concur. It's like the whole pipeline is part of the model, so to say. It's all involved in it. So.
Tim, do you want to share some takeaways from the book you read, maybe, to wrap this one up?
I have to go in a minute, but I'm happy to. Yeah. So basically, I was just looking for some resources for learning a bit more, and saw that sorry, I forget his name already. Was his name Alex posted that he found this book really useful, and it was an easy read. I read through it in a week or so, and it was about sort of just designing objects in object-oriented programming, and I know a bit about OOP, but not like any sort of like best practices for how you design objects and how you what's the best practice. So I think the sort of the biggest, and this is kind of a stupid example, but the most concrete thing is that I took away from it, and something that I've been able to put into practice pretty immediately, and the project I'm working on is this idea of using abstractions when you're dealing with anything outside the boundaries of the application of the software that you're developing. So if you're calling any sort of whatever external service, that you write abstractions for that, and use things like dependency inversion from the solid principles to sort of abstract those things away and make it a much more robust system. So that's something I've put into practice even just in the last week or two since reading that book. And I think also from reading Laszlo's one of his blog posts recently, where he was talking about the patterns, and we had a little discussion about how you could use this simple thing, the dependency inversion in that. But another thing I found useful was the talking about this distinction between service objects, which you use to perform some sort of task or return a piece of information, and then separating those from sort of value objects or entities like models. I think this is a really useful sort of mental model to have when you're thinking about, okay, I'm going to create some object to represent something, what is it actually doing, and having to really think through those steps, I think was really, for me, a good thing to beat into my head a bit. And I think that goes sort of in the direction, I don't really know much about it, but in the direction of sort of the domain-driven design. And maybe the last thing, again, sort of this distinction between methods within objects, like query methods that you use for retrieving information, and sort of how you treat those versus command methods where, you're just performing some sort of task. Again, this is when you're writing methods in classes, these things were really, really useful for me. But back to the point I was making earlier is sort of, again, how to like implement this into my work is still, it's a tough thing, because specifically this book, there's a lot of the examples seem to be coming from, the guy that wrote the book seems to be coming from sort of a more web application background and coming from an object, like a language. I'm not sure which one he specifically is an expert in, but it seems in the direction like Java, where everything is basically objects, and like knowing how to like translate that into, I'm working mostly in Python, like knowing, is it always good to be using classes? It probably isn't. It's not really Pythonic, so to say. And when to use these things and that sort of stuff. And I think the point I made earlier, I think it just comes with experience, and that's something I've taken away from reading this book and lots of any other books about sort of software engineering, hardcore software engineering sort of things. So.
Yeah. There was a lot of good points, and I think what you mentioned on services and value classes or data classes, or this kind of tactical and strategic level. So what we speak most of this conversation was almost all tactical, and we haven't spoke about like structuring. And these are not like I read your notes on Andre on that, and these are not exclusive. It's like sometimes you perform strategic programming when you are starting a project. Imagine in big picture the things of what should happen, and then you start implementing it, refactoring, testing, tactical issues, readability, and then you sometimes refer back to the strategy whether you are still solving this problem. And maybe it's an advice for team. It's like when you're overwhelmed by all of these new components, is like you need to have like goals, what you try to achieve. And then you need to know whether a goal can be achieved by applying a certain technique. So, for example, dependency inversion is a typical issue, and this is why the first blog post talks about dependency inversion so early, is because that is a goal towards enabling testability, decoupling yourself from production systems, and then you can test in isolation without actually calling the database and slowing things down. But that was justified there. You don't really need to do dependency inversion all the time. It's like it's kind of like a code smell, which is like you decide whether it's there is fire or not. So I think that's an important thing. And then I think maybe we can have an entire reading group on strategic design and
for sure that would be awesome as well.
Yeah, maybe one last point. And I think from my perspective, how I get over that hurdle of like being kind of like frozen with, okay, what should I do in this situation, is try to make the best decision, but always knowing that like refactoring is going to be part of the project, and like I'm probably going to make some bad decisions along the way, and just like it's just part of the process, and you're not always going to design things perfectly from the beginning. You're going to get new information, and just like that you have to build that into the culture of whatever, always refactoring.
Yeah, maybe as a closing argument, you are deliberately not trying to write it correctly. You know, it's like the confidence that you have refactoring capabilities and testing allows you to make mistakes, because then you can fix it later. You know, and this is why what's the name, red-green refactor, you know, process core is that, you know, that, you know, write something, solve the problem, and then refactor it. But that requires tests.
Great.
Great.
I have to run, so
awesome session, guys.
thank you very much, guys, for inviting me, and thanks for the great discussion.
Thank you very much. Thank you very much. It was a great conversation. Thank you.
Okay.
For sure. Thank you
Bye,
so
everyone.
much. Goodbye.